These are the notes that you should have copied with the sub while I was gone. Covalent bonds are between two nonmetals. So the first one is a nonmetal. The second one has to be a nonmetal. So if you look on the periodic table, it is located on the right side of the zigzag line. First, we're going to go from name to symbol. So just like when we did ionic bonds, we're going to find the symbol of the first nonmetal and write it as is. Then we're going to find the symbol of the second nonmetal and write it as is. And last, prefixes become subscript. Remember, prefixes come before the root word. Subscripts are the small numbers at the bottom. In order to do covalent bonds, you need to memorize the prefixes. 1 is mono, 2 is di. Di stands for 2, not bi, di. 3 is tri, like a triangle. 4 is tetra, like a tetrahedral. Number 5 is penta, like a pentagon. 6 is hexa, like a hexagon. 7 is hepta. 8 is octa, like an octagon. 9 is nona. 10 is deca, like a decade. You need to memorize these prefixes. The prefixes will not be given to you. In addition, you will use the same prefixes when I teach you how to write hydrates. So for the first one, antimony, Sb on the periodic table. Bromide is bromine, which is Br. So if I look at antimony, there is no prefix, so that means it is 1. Tri is 3, so the prefix becomes subscripts. We do not crisscross. Number 2, hexaboron, silicide. Boron is the element, so that's a B for boron. Hexa is 6. So the subscript is 6, silicon, which is Si. This is actually written incorrectly. This should be mono silici, which stands for 1. So it's B6, Si. Next, chlorine dioxide. Chlorine, Cl. There's no prefix, so that is a 1. Subscript. Oxide is oxygen, O. Prefix is di, which stands for 2, so ClO2. Pause the video, finish 4 through 8, and then check your answers. Hydrogen iodide. So this should be hydrogen monoiodide, if it was written correctly. Hydrogen is H, no prefix, so it's just 1. Iodide is iodine, which is I, mono, which is 1, so it's HI. Next one, iodine pentafluoride. Iodine is I, no prefix, so it's 1. Fluoride is fluorine, which is F. Penta is 5, so the subscript is 5. Dinitrogen trioxide. Nitrogen is N. Di, the prefix means 2. Oxide is oxygen, O. Prefix is 3. So if you notice the pattern, the prefix becomes the subscript for that particular element. You do not look up charges. You do not crisscross. Do not reduce. Ammonia is a special one. I would not give you one of these on the test. Ammonia is same thing as it's nitrogen, trihydride. So nitrogen is N, no prefix, so there's 1. Hydride is hydrogen, which is H. Tri means 3, so the subscript is 3. Phosphorus triiodide, phosphorus is P. Iodide is iodine, I. There's tri in front of it, it becomes a subscript 3. Again, the prefixes that are modifying the nonmetal goes with the nonmetal. Do not crisscross. Now we're going to go backwards. We're going to go from symbol to name. The procedure is very similar to ionic naming. So we're going to find the name of the first nonmetal and write the name as is. We're going to find the symbol of the second nonmetal. Remember, nonmetals are located on the right side of the zigzag line, except for hydrogen, which is located in group 1 because it has the same number of valence electron. So find the symbol of the second nonmetal, drop the ending, and add IDE, just like we did before. And whatever subscripts now become prefixes. We always use prefixes except for the first nonmetal. The first nonmetal, if it's for 1, there is no prefix. But the second nonmetal, if there is 1, we always use a prefix. Number 9, phosphorus is the first nonmetal. So we write the name as is. The subscript is 4. 4 is tetra, so we write tetra in front. So this is tetraphosphorus. The second element is sulfur. Just like we did in ionic bonding, we drop the ending and add IDE. So this is sulfide. The subscript is 5, so this is penta. So P4S5 is tetraphosphorus pentasulfide. Again, first nonmetal, we don't change the ending. The second nonmetal, we do change the ending and add IDE. Number 10, first element is nitrogen. So we write the name as is. There is 1 nitrogen. For the first nonmetal, we do not use a prefix for 1. So we don't say mononitrogen, we just say nitrogen. The second nonmetal is oxygen. Drop the ending and add IDE, so this becomes oxide. Subscript is 2, so this is dioxide. So nitrogen dioxide. So pause the video, complete 11 through 16, and check your answers. SCF6, SC selenium. So we write the name as is. There is only 1 selenium because the subscript is 1. Again, for 1, for the first nonmetal, we do not use a prefix. The second nonmetal is fluorine, becomes fluoride because we drop the ending and add IDE. There's 6 of them. 6 is hexa. So selenium hexafluoride. Number 12, Si is silicon. First nonmetal, we write the name as is. It has a subscript of 2, so that's disilicon. The second nonmetal is bromine, which is bromide. We drop the ending and add IDE. The subscript is 6, so it becomes hexa. So disilicon hexabromide. Number 13, SCl4. First element is sulfur. We write the name as is. Prefix is 1 because the subscript is 1, so we don't write 1. Second element is chlorine. Drop the ending, so it becomes chloride. The subscript is 4, which is tetra. So it's sulfur tetrachloride. Number 14, CH4. First one is carbon, so we write carbon. Name as is. Prefix is 1, so we don't need a prefix. The second element is hydrogen, which becomes hydride because we have to drop the ending and add IDE. There's 4 of them, so this is tetra. It's a carbon tetrahydride. Next one, B is boron, so we write boron, name as is. The prefix is 2, so this is diboron. Second element is silicon, so it becomes silicide. Drop the ending and add IDE. There's one silicon, so we must write a prefix. We write mono. Second nonmetal always gets a prefix. It's only the first nonmetal that we do not write a prefix for number 1. NHF3, N is nitrogen, so we write the name as is for the first nonmetal. There's only one of them, so we don't write a prefix. The second element is F, which is fluorine, becomes fluoride. There's 3 of them, so we write trifluoride. So nitrogen trifluoride. When naming acids, we look for oxygen. Usually if it ends in IDE, it is the periodic table. Because every single time we name a nonmetal, we drop the ending and add IDE if it's off the periodic table. We ignore oxygen because when we look at oxygen and combine it with hydrogen, it just becomes water. So general format for naming acid is all the periodic table elements must have hydro in front, and there's a root, ic, and then acid. If there is an oxygen present, it's going to have an ate or a ite ending, and this is your polyatomics. There are some exceptions. So you have like cyanide. Cyanide is Cn-1 that has no oxygen, but it's still a polyatomic. So polyatomics, so we use our chart and we look for the ate ending or the ite ending. If it's an ate ending, it's going to be the root of the word ic acid. If it's an ite ending, it's going to be root us acid. Periodic table, which means there is no oxygen. And polyatomic, where oxygen is present. So if it's off the periodic table, we know it ends in IDE usually. So the general format for writing an acid is hydrorutic acid. If there's oxygen present, there's some exception. It's going to end in an ate or an ite. And so this is going to be rutic acid or rutous acid. So let's look at the following acid. In general, right now, all your acids will begin with an H, except for the last one, which I'll explain. So HCl is an acid. It starts with an H. There is no oxygen present. Since there's no oxygen present, this is off the periodic table because you know chlorine is usually chloride when we write it in nomenclature. General format is going to be hydro root ic acid. So HCl, no oxygen, so we're going to do hydro. The root, chlorine is chlor, is my root. Ic, just like we drop the ending INE and add IDE, we drop INE and write ic acid. The second one has oxygen present. So I look up the polyatomic. The polyatomic here is carbonate. Since it has 8 as an ending, we know it's going to be root ic acid. There is no hydro in front, so this is carbonic acid. So your root is carbon. Here's my ic and the acid. The next one also, oxygen is present. So I look up my polyatomic, which is NO2. So NO2 is nitrite. It's a polyatomic, so it's a ite. So that's going to be root plus us acid. So that's going to be nitrous acid. So my root here is NITR. We have our us and then my acid. Pause the video and finish the last four and then check your answer. Next one, HNO3 has an oxygen. I look up NO3, which is nitrate. Since it ends in an 8, it's going to be rutic acid. So this is nitric acid. Next one here, SO3. Again, oxygen is present. SO3 is sulfite. So this becomes no hydro. We know it's going to be rutous acid. So this is going to be sulfurous acid. Next one is H2SO4. Again, this is a polyatomic because the oxygen is present. So I look up SO4, which is sulfate. Since it ends in 8, we know it's going to be root plus ic acid. So this is going to be sulfuric acid. My root is sulfuric acid. This one can be written CH3 COOH, or it could be written HC2 H3O2. Since oxygen is present, I look up the polyatomic. Whether I look up this one or this one, we know it's acetate. It ends in an 8, so this becomes acetic acid. So this is the only acid that you will have in this class, which the H could come in the back or H will come in the front, depending on which way acetate ion is written. So in general, for acids, when we name them, the first thing we do, is there an oxygen present? If there is no oxygen present, it is the element off the periodic table. It must take hydrorootic acid. You must add the hydro in front. If there's an oxygen present, it's a polyatomic, and you look that up on your polyatomic sheet. If it is an 8, the general format is rootic acid. If it's an 8, it's rutous acid. There is no hydro. Let me show you an example. So we have H3P, we have H3PO3, and we have H3PO4. How are these different? So we have H3P, no oxygen present. This is off the periodic table. So the general format is hydro plus root plus ic acid. So this one becomes hydro. My root is phosphor. And then ic acid. The next one is H3PO3. This one, oxygen is present, so I look up the polyatomic. The polyatomic is phosphite. So general format for that is root us acid. So this becomes phosphorus acid. H3PO4. Again, oxygen is present, so we look up the polyatomic PO4, which is phosphate. And the general format for 8 is root ic acid. So this is phosphoric acid. So this is how you differentiate. Periodic table has a hydro and it's a ic. If it's a ite, which means oxygen is present, there is no hydro and it's a us. If it's a phosphate, which is oxygen is present, it is no hydro and a ic. These are also polyatomics that apply to the halogen group. They can have up to 4 different oxygens. You do not have to copy these. These are also on your polyatomic chart. However, you need to note that the halogens are interchangeable, the Br, the Cl, and I, but the format is all the same. So when it has 3 oxygens, it is called an 8. So for example, if we have bromate, it has 3 oxygens. 1 less oxygen is an ite. So if you notice, there's 1 less oxygen. And so if we have 1 less oxygen than the ite, it is hypo. This is not hydro, this is hypo. It is called hypobromite. If it has 1 more oxygen than the 8, this is BrO4 minus, and this is per. This is called perbromate. So what they do is they add a prefix for 1 more and 1 less. It is the same format. Perbromate, perchlorate. Only thing that changed was the root, but they both have 4 oxygen. Periodate, again, it is only the root that changed, but it has 4 oxygen. If it ends in an 8, it has 3 oxygens. If it has 1 less, 2 oxygen, it's an ite. And if it has 1 less oxygen or 1 oxygen, is hypoite. Hypoite and hypoite. And you do not have to memorize these. These are already on your polyatomic sheet. However, the format for naming the acids is still the same. It is root-ic acid for the 8 endings. 8 ending, again, root-ic acid. For the ite endings, it's still root-us acid, root-us acid. The only difference is if it's perbromate, we must stick the per in front. If it's hypobromite, we must put the hypo in front. This is not hydro, but hypo. So going in the reverse direction for acids, name to symbol, it is the same process as ionic bonds. So the first thing we're going to do is write H and its charge, because every single one of your acids begins with a hydrogen, except for acetic acid. Depending on which version of the ion you use, the H could be in the front or in the back. So all your acids right now will begin with an H. So you write H, the charge of H is going to be a +1 because it's going to behave like a metal. Next thing, you're going to write the nonmetal or the polyatomic symbol with charge. You're going to crisscross down. And again, acetic acid, H can be in the front or the back. So all of these are acids because they end in acid. So we're going to start with an H in front. H has a charge of 1. It's chloric. Since it has hydro, it is off the periodic table. So this is chlorine, which is Cl, charge of 1, crisscross. So this is HCl. Next one. Again, it starts with an H. So I'm going to write H and its charge, which is 1. It says hydro. So this is off the periodic table. Iodic is iodine. So that's I with charge of 1, crisscross, HI. Nitric acid. Again, we're going to start with hydrogen, charge of 1. Since there is no hydro, we know this is a polyatomic. It is a ic ending. We know the ending is 8, so this must be nitrate. Nitrate is NO3, charge of 1, crisscross, HNO3. Pause the video, try the last 3 on your own, and then check your answers. Sulfuric acid. Again, we start with a hydrogen, charges 1. No hydro, so this is a polyatomic. It's a ic, so the ending is a 8. So this is sulfate. Sulfate is SO4, charge of 2. We crisscross down. 2 comes down here. The 1 comes down here. So this is H2SO4. Phosphoric acid, again, starts with a hydrogen, charges 1. No hydro. It's a ic, so this is an 8. This is phosphate. Phosphate is a polyatomic, PO4, 3 minus. Cannot reduce, so I crisscross down. So this is H3PO4. Carbonic acid, again, is going to start with a hydrogen. No hydro, so this is a ic, so this is an 8. This is carbonate, which is CO3, 2 minus, crisscross down. So this is H2CO3. When naming acids, the state of matter will determine how rules are written. If it's in a gas state, we use the covalent rules. Covalent rules mean we find the name of the first nonmetal, write the name as is. We find the name of the second nonmetal and drop the ending and add IDE, and prefixes become subscripts. Find the first nonmetal and write the name as is, which is hydrogen. Cl is the second nonmetal, drop the ending and add IDE. We do not use prefixes for 1 for both nonmetals, so it becomes hydrogen chloride. If it's in the aqueous state, we use the acid rule. So Cl has no oxygen present, so we must add the hydro. It is off the periodic table. Root is chloric acid. Hydrates are ionic compounds that include water molecules in your crystal structure. You will use the same rules for ionic compounds, but we're going to use the prefixes that we learned for covalent bonds. From symbol to name, name ionic compounds as before. Find the name of the metal and write the name as is. Find a nonmetal, drop the ending and add IDE, or if it's a polyatomic, write the name as is. For the hydrate compound, we will use coefficients that will become prefixes. The prefixes are the same as what we learned in covalent bonding. So the general format is ionic compound, your prefix from your covalent plus hydrate. 4 parentheses 2C2O4.H2O. As a metal, so it's ammonium. So I found the name of the first, which is the metal, and I wrote it as is. The second one, this is a polyatomic. It is oxalates. It's a polyatomic, so we write the name as is, oxalate. We have water. The water is named as hydrate. There is one water, so we write the prefix monohydrate. The second one, Ca, we find the name of the metal and write it as is, that's calcium. Cl is a nonmetal off the periodic table, so we find it and drop the ending and add IDE, so this is chloride. Water again is hydrate. There's 2 of them, so this is dihydrate. Pause the video, finish the last 3, and then check your answer. NaC2H3O2, dot 3H2O. Na is the metal, so we look that up. This is sodium. C2H3O2 is a polyatomic, so we write the name as is, as acetate. Again, H2O is a hydrate, so we just write hydrate. There is 3 of them. Prefix for 3 is trihydrate. So sodium acetate, trihydrate. The next one, Fe, is a metal, so that's iron. We write the name as is. This is a transition metal, so I need my parentheses. This is PO4 is a polyatomic, so we write the name as is. Remember to find the charge of the metal. Charge of the metal is equal to the number of nonmetals, or poly, or times charge of nonmetal, or poly, atomic, over the number of metals. So the number of polyatomic, there's 1 phosphate. The charge of phosphate is 3. There is 1 metal, Fe, so that's 1. So 1 times 3 divided by 1, so the charge of iron is 3. H2O is hydrate. There's 4 of them. Prefix is tetrahydrate. Last one, Cu is copper. This is a transition metal, so I need to put a parenthesis around it. SO4 is a polyatomic sulfate, so we write the name as is. Water, again, is hydrate. There's 5 of them, so this is pentahydrate. We need to find the charge of copper. There is 1 sulfate. The charge of sulfate is 2. There's 1 copper, so the charge of copper is 2. So you write the first part, which is like ionic compounds. After you write the name of your ionic compound, you write hydrate for water and the appropriate prefix in front of water. Going backwards from name to symbol, we write the symbol for the ionic compound as we did before. So find the symbol, find its charge, find a nonmetal or polyatomic and charge, reduce, crisscross down, parentheses for more than 1 polyatomic. Prefixes become coefficients. So the general format is the symbol for the ionic compound. Dot here does not mean multiply. It's just a format. You put the dot, the coefficient. So whatever the prefix is now becomes the coefficient, and water for hydrates. The first example is cobalt 2 chloride hexahydrate. Symbol for cobalt is CO. The charge is given as 2 because this is a transition metals. Remember, transition metals are located from groups 3 to 12, tin and lead. Chloride is chlorine. Cl, charge is 1. I cannot reduce, so I crisscross. The 2 comes down here. The 1 comes down here, so this is CO. Cl2. I need my little dot here to tell me that it's surrounded by water. Hydrate, remember, is H2O. Hexa is 6, so we put 6H2O. Next one, magnesium sulfate. Magnesium is Mg. Charge is 2. Sulfate is a polyatomic. SO4, charge is 2. These 2 are reducible. So this becomes MgSO4. I need my dot. It's a hydrate, so we write H2O. Hepta is 7, so we write 7. So MgSO4 dot 7H2O. Pause the video, finish the last 2, and then check your answer. Barium. Ba, charge 2. Hydroxide is a polyatomic. OH1. Cannot reduce, so we crisscross down. Ba. Since there is more than 1 polyatomic, I need a parenthesis around the OH. 2. Dot, hydrate again is H2O. Octa is 8, so there's an 8 in front. Last one, sodium is Na. charges 1. Carbonate is CO3, charges 2. I crisscross down, so this is Na2CO3. The 2 from the carbonate goes to the sodium, the 1 goes to the carbonate. Again, dot. Hydrate is H2O. Deca is 10, so we put 10. So the only thing you do differently is you put a dot and you water.